definitions of the angle pairs that we're going to be talking about. 3-2, however, is talking about the properties of parallel lines. So we're really only going to be interested in transversals when a transversal is cutting parallel lines. And so 3-2 is going to talk about the properties that occur with our angles when we have parallel lines and a transversal. We have 4 different statements or postulates and theorems that talk about these relationships with our angles. So let's go ahead and put them up here. The first statement we're going to talk about is postulate 3-1, which is called same side interior angles postulate. And same side interior angles postulate says if a transversal intersects 2 parallel lines, then same side interior angles are supplementary. And we're talking about same side interior angles. In this case, we would be talking about same side, like 3 and 6, and their interior. So 3 and 6, and angles 4 and 5. And it says they are supplementary. And remember, the supplementary simply means that they add up to 180 degrees. So right here, 4 and 5, measures of angles 4 and 5 add up to 180, and measures of 3 and 6 add up to 180. Those are 2 pairs of same side interior angles. Notice we don't talk about a same side exterior angles postulate, but technically it works for them as well. So although it's not listed on here, angles 1 and 8 are same side exterior, and so are 2 and 7. So we could go ahead and add that. I wrote that right in here. Measures 2 plus 7 is equal to 180, and measures of angles 1 and measure of angle 8 is equal to 180 degrees. Then we have alternate interior angles. Alternate interior. Remember, alternate means they're on opposite sides of the transversal. Interior means they're inside of our parallel lines. So our alternate interior angles, 4 and 6, and 5 and 3. And if we were to look at those angles, angle 4 and 6, those are both acute angles, and if these lines are parallel, they will be congruent. Likewise, 5 and 3 are both obtuse angles, but they will also be congruent to each other. So we have that right there. And since we just talked about alternate interior angles, I usually like to go to alternate exterior angles. Alternate exterior, opposite sides, but exterior or outside of our parallel lines. So we have angle 1 and 7 will be congruent. We're down here. And angles 8 and 2 will be congruent as well. Those are alternate exterior angles. Then to pick up the last ones we did not talk about, it's the corresponding angles. And remember, corresponding angles are on the same side of the transversal. One is exterior and one is interior, and they are not adjacent. So angles 1 and 5 are corresponding angles, and they are congruent. Angles 2 and 6 are corresponding angles. Likewise, angles 3 and 7 are corresponding angles, and 4 and 8 are corresponding angles. So notice with corresponding angles, we actually have 4 pairs of congruent angles. So all of these postulates and theorems simply state that if we have parallel lines, if these 2 lines are parallel and we have a transversal, then all of this stuff here is going to be true. We're going to have all these either supplementary angles or we're going to have congruent angles. So let's go ahead and look at an example where we have to use this information. So here's a picture, and notice we are talking about parallel lines. Again, we know they're parallel from this extra set of arrowheads, and oftentimes we might actually have real arrowheads, but the parallel line arrowheads are somewhere in the middle, not right in the middle, but usually towards the side. And so these 2 lines are parallel, and so now we look at our angles that we're talking about. Let's look at this angle up here, the 7y plus 27, and this angle right here, 125 degrees. These 2 angles are opposite, but they're exterior. And so if we were to go back and look at our postulate or theorem of alternate exterior angles, we'd say that they are congruent. And so since these angles are congruent, we can go ahead and set up our equation that we have 7y plus 27 is going to equal to 125. And then all we have to do is solve for y. So solving for y, we end up with y is equal to 14. Then we can go back to our problem and let's try to solve for x. Well, here x is 15x minus 5 and 125. If we think back to what we've already learned, these two angles here are a linear pair and thus they are supplementary. So to solve for x, we set up that equation. So we set up the equation 15x minus 5 plus 125 equals 180, and solving for x, we would get x is equal to 4. So here's another example that might not look exactly like the pictures we've been talking about. So we have a trapezoid. A trapezoid, definition of a trapezoid is it has two sides that are parallel. So these two sides here are marked parallel. You can see the parallel markings right there and there. Therefore, the other two sides, these two sides here, are our transversals. Notice the transversal intersects parallel lines. So to maybe make this a little bit easier to see, we can extend our lines a little bit. So we extend these two sides, our parallel lines, and this side here we extended our transversal, and now if we move this a picture away, we can see that these two sides, or these two angles here, 2x and x minus 12, are same side interior angles. Same side interior angles are going to be supplementary. So we can write our equation such. And we get this equation here, and we can simply solve that for x. Likewise, we could do the same thing for y. 3y and y plus 20 will also be same side interior angles, so they will also add up to 180 degrees and are supplementary. Therefore, we get these two equations that we could solve for x and y. And then if we wanted to, we could then substitute the values of x and y back into the statements here to figure out the angle measures of our trapezoid. Okay, that is it for this lesson. I would like you to go back to the previous screen and answer the questions that are posted there in the Google form, and don't forget to hit submit. Thanks for watching.